Thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello, everyone, and welcome to the week 17 of the Concentrator Talk. Thank you for joining us today. This is brought to you by the Oxygen Alliance. My name is Amarpreet Rai, and I'm pleased to be hosting the Concentrator Talk today from New York. I am joined by my colleague Timothy Matonga from Lilongwe, Malawi. For those who may not be aware, Concentrator Talk is a virtual meeting that the Auction Alliance hosts every Thursday from 2 to 3 p.m. Central African Time to discuss different aspects of concentrator assessment, use, and maintenance. Today, we are joined by a usual mix of technicians. We have Kulwinder Singh from Chandigarh, India, from Sanrai. We have Mwawi Lungu, Sharon Ngozo, Mtedo Sinjani, and Cynthia Chikomoni from Open02 in Malawi. And today we thought we would start it off by doing something a little bit differently because we do have a bit of a smaller group. We thought we would kick it off by some of our technicians and guests sharing some things that they've worked on this week. I think there's been some exciting things to talk about. So we are looking to make this a little bit more interactive. So please, anyone who wishes, please feel free to share something that they've worked on this week that was interesting, maybe a fun challenge they saw, maybe an unusual patient. Sometimes we see really crazy devices come in. The floor is yours, and we will sit in a little bit of silence until we hear some responses. Please go. I saw him. Yes,
Yeah.
please.
Yeah. So actually, this week we had Paulina from Sunlight. She joined us this side at Open02 in Lilongwe, Malawi. So it was a pleasure whereby we finally got to see the method of refilling sieve beds using the snowfall method. And yeah, it was quite interesting. Sure.
Wonderful. Thanks, Mtedo. Thank you for sharing. Masofa or Daniel, did you guys see anything interesting or fun this week?
On my side, nothing new.
Just another day in the office.
Yeah.
All right. Well, let's get started with our first question then. So our first question is, I am a technician for a mission hospital that is yet to be opened, and we would like to purchase equipment for oxygen therapy. The clinicians prefer using oxygen cylinders compared to oxygen concentrators. Is there any difference between purchasing oxygen cylinders and oxygen concentrators? Which of the two would you recommend us to buy? And Sharon, if you could please answer this question.
Thank you, Amapli. Okay, so an oxygen cylinder contains oxygen under pressure and has a pressure gauge which gradually falls as the oxygen is being depleted. So to use these cylinders, you need a pressure regulator and a flow meter to which a line of tubing is connected and a nozzle cannula or oxygen mask on the end. And in this way, oxygen in the cylinder can be delivered directly to the patient's nose. So as we can see on the graphics, we have an oxygen cylinder and delivery. So I'll talk about the advantages and disadvantages of an oxygen cylinder over an oxygen concentrator. So I'll start with the advantages. Firstly, so no power is required to supply oxygen to the patient when you're using a cylinder. Secondly, an oxygen cylinder does not produce noise worst in use as it has no associated alarms or a compressor, which is a source of noise in an oxygen concentrator. Thirdly, an oxygen cylinder have a lower initial cost. And lastly, you can achieve higher flow rates for oxygen. So now I'll talk about the disadvantages of the cylinder over a concentrator. So an oxygen cylinder is heavy and lacks portability. They also have a limited amount of oxygen, and as such, it needs to be refilled or replaced once the oxygen is depleted. Also, oxygen cylinders have a greater running cost as they need to be refilled or replaced frequently. Lastly, the cylinders have no warning alarm when the oxygen is running out or has run out. So, oxygen concentrators are devices that concentrate oxygen from ambient air by selectively removing nitrogen and supplying oxygen enriched air to a patient. So, newly purchased oxygen concentrators have the output pressure factor set and therefore need no readjustment. So, to use an oxygen concentrator, you have to set the flow meter to the desired flow and use it with a cannula or a mask. And now I'll talk about the advantages and disadvantages of the oxygen concentrator over an oxygen cylinder. So the first advantage, an oxygen concentrator provides an unlimited supply of oxygen as it is able to continuously draw in air and trade it by removing nitrogen. So this means that an oxygen concentrator will never run out of oxygen, unlike an oxygen cylinder. The second advantage, the concentrators are notably lighter and portable than oxygen cylinders. So a concentrator do not rely on pressurized oxygen and thus do not need a dense tank. And the last advantage, oxygen concentrators have a cheaper running cost as compared to oxygen cylinders. And then I'll talk about the disadvantages of an oxygen concentrator over a cylinder. So the concentrator rely on a battery or electric power to perform the air filtering or oxygen flow. They also have a higher initial cost. And thirdly, oxygen concentrators, they produce noise from the compressor and alarms that come with them. So an oxygen cylinder would deliver the same desired flow at a regulated pressure, usually 20 psi, just like an oxygen concentrator. The only major difference being that the cylinder will run out of oxygen after some time, while an oxygen concentrator will continue producing oxygen until the molecular sieve responsible for removing nitrogen from air loses its effectiveness. So looking at the above factors, I would recommend one to purchase an oxygen concentrator for long-term use and an oxygen cylinder for short-term use. Thank you.
Thank you so much, Sharon, for that very detailed explanation. I think this is a question that comes up quite often, and it's a decision that hospitals are forced to make or clinics are forced to make quite often, as well as patients. Does anyone have any questions or comments on this, or any other technicians want to add something before we move on? Okay. We will, through the Alliance, there are several tools that are out there to help facilities or government organizations make the decisions of what fits their budgets and their requirements for whether to use cylinders or concentrators. So in our recap email tomorrow, we will share some links for some of those tools so everyone can get access to those as well. Okay, we'll move on to our next question. So the question is, I have a faulty J5 at our workshop, which needs new sieve beds. Upon servicing the concentrator, I seem to have misplaced the pipe connecting the two sieve beds, which had an orifice in it. Is it okay if I use a pipe without an orifice inside it? And if not, what is the function of an orifice used inside the pipe? Cynthia, could you please answer this question for us?
Yes. Okay, so orifices found in the air pathway of an oxygen concentrator have precisely sized small holes that limit the flow of oxygen. In an oxygen concentrator, orifices are used to allow a limited amount of oxygen to flow into the pressurized sieve beds. So this is done to push out any remaining nitrogen left behind while purging. So since the orifices reduce the size of the air pathway, it actually reduces the amount of oxygen going into the pressurized sieve beds. So to answer your question, it is not recommended to use the pipe without the orifices because more oxygen will be wasted during the depressurization process by reducing the amount of oxygen flowing to the product tank of the concentrator and eventually reduce the oxygen purity as well as the output flow. Thank you.
Thank you very much, Cynthia, for that explanation. And now we are coming to our first poll. So while I launch that, Mwawi, would you please explain how to access the polls?
Yes. So if you are joining us from your mobile phone, if you go to the bottom right of your screen, you will see the menus option there. So if you click on the menus option, in the window that opens, you'll see the activities button as one of the options listed. So if you click on the activities button, that will take you to another window where the pause menu option is listed. If you are joining us from your computer, then just go to the bottom right of your screen as well. And the activities button is the icon on the far right. So just click on that. And in the window that opens, you will be able to see the pause menu as one of the options listed. Thank you.
Thank you, Maui. So our first poll question is, have you ever replaced a pipe with an orifice with a pipe without an orifice? So all of the votes that we've gotten are a no. So it seems like all of the technicians today already knew what the orifice does and the importance of it. So that is great. It was certainly new for me. So thank you. Thank you, Cynthia, for that. And we will move to our next question. And our next question is, I have a DeVilbiss 525 oxygen concentrator that is producing 80% oxygen purity at 5 liters per minute after servicing everything on the concentrator and refilling its bed with sodium-based zeolite. I did the leakage test as well, and it was negative. I would like to know if the concentrator can still be used on a patient at lower liters since it is producing 93.4% oxygen purity at 3 liters per minute, and any advice on how best I can prevent the users from putting the flow above 3 liters per minute. So that is a bit of a complicated question. Sharon, if you could take this one, please.
Thank you. So the most common type of zeolite used in the oxygen concentrators during the pressure swing absorption process is the zeolite 13X. So the zeolite can be sodium-based, lithium-based, or a combination of both sodium and lithium, depending on the size of the sieve bed and the choice of the oxygen concentrator manufacturers. So for example, you may notice that the company that produces DeVilbiss concentrators uses lithium-based zeolite in 525 oxygen concentrators, which has smaller sieve beds, and sodium-based zeolite in 515 DeVilbiss oxygen concentrators, which have bigger sieve beds. So this is so because lithium-based zeolite has an outstanding nitrogen to oxygen absorption selectivity than the sodium-based zeolite. So in your scenario, it is normal for you not to have the higher oxygen purity at 5 liters per minute in DeVilbiss 525 oxygen concentrator, even after having completed the entire fixing process of the oxygen concentrator. So I would advise you to use lithium benzoate if you want to get high oxygen purity at 5 liters per minute. And yes, you can use the concentrator on 3 liters per minute on patients that do not need high flow of oxygen. For example, infants or children below the age of 2, they receive oxygen therapy at 2 liters per minute. So, but since advising the users of setting the concentrator below the 2 liters per minute can be hard sometimes due to communication barriers, I would advise you to use a needle valve on the outlet of the flow meter to prevent any problems that may arise if the concentrator is producing oxygen below the recommended oxygen purity. So, from the graphics we can see a needle valve. So a needle valve is a type of valve with a small port and a threaded needle shaped plunger. So it allows precise regulation of flow, although it is generally only capable of relatively low flow length. So during your installation, you will have to make sure that you put the needle valve pointing in the right direction. So the needle valve has an arrow to which side it shows which side the air has to flow to. So you have to make sure that the valve is fully open as well as the knob on the flow meter. So this will allow free flow of air to the patient's outlet. So from the graphics, we can see the picture on the left, the arrow shows the adjusting knob, and the picture on the right shows the rocking mechanism. So what you have to do is you need to start turning the adjusting knob on the needle valve clockwise or clockwise to either restrict the flow or increase the flow of air passing through the needle valve respectively. So you'll notice that the ball in the flow meter will start dropping. That is when you're restricting the flow. And when it gets to your required flow, you have to use the locking knob to lock the valve. So doing this will only allow air to flow at your desired flow rate, that is at the patient's outlet. Thank you.
Thank you very much, Sharon, for that detailed explanation. We are going to launch our next poll, and that poll is: have you used a needle valve to control the airflow rate before? And while we are waiting for those questions or those poll results to come in, does anyone else have any questions or comments? I think this is a challenge that we see quite often where flows or flow meters are being opened further than they should be. And this seems like a great solution, especially for this type of a problem. So any other comments or questions on this? Wowie, please.
Yeah, so maybe just to make it clear that this is not a pressure regulator. So maybe someone might think that why not just adjust the pressure regulator? If you adjust the pressure regulator, then it will mess up the output on your flow meter, because different flow meters are adjusted are supposed to operate at different pressures. So that's why we encourage using the needle valve, because you're still maintaining the same pressure. You are just controlling the output flow using the needle valve. Thank you.
Thank you, Maui. That was a great addition. Any other comments or questions? Okay, so our poll results have come back and there was only one vote for yes. Everyone else has said no. So Sharon, I think this was a particularly useful question that you've answered for everyone here. Our next question. I have a personal portable oxygen concentrator, a POC, that does not have a humidifier connection. Can I still use it? Gulwinder, if you can please take this question.
Thanks, Anpreet. So a portable oxygen concentrator works same like the stationary oxygen concentrator. It produces oxygen in the process. The nitrogen and the oxygen are separated to the pressure swing adsorption process. That is the same for both. So the portable oxygen concentrator produces less airflow than the larger stationary oxygen concentrator that can produce up to 10 liters. But the portable ones, that maximum capacity, it can be only up to 3 LPM in the continuous mode, and pulse settings can be up to 6 settings. So there are different kinds of portable oxygen concentrators, of which some of are pulse flow only, so only POCs, while some are continuous and pulse, both modes they are having. So in your case, it may happen that your portable oxygen concentrator is a pulse flow POC. So that is it delivers oxygen to the patient when the patient inhales, means it delivers oxygen only when the patient triggers. So it does not deliver during the exhalation. So this does not cause any dryness in the airways of the patient, unlike in the continuous flow of the oxygen, which leads to dryness of the airways. Therefore, humidification is not required. However, if your portable oxygen concentrator has a continuous flow option, that also mostly the humidification is required above the 4 liters per minute oxygen requirements. So in that case, it is not required. But if it is required, then you can call the equipment provider to provide the humidifier for that use. Thank you.
Thank you, Kulwinder, very much for that. We have our next poll question. And the question is, have you repaired a pulse flow portable oxygen concentrator before? And while we are waiting for answers, does anyone have any comments or anything further questions that they'd like to add? Okay. I think on a future session, we will talk more about the differences in these types of equipment, especially for compared to the stationary oxygen concentrators. So the votes are in, and it's quite split. So it seems like some people have worked on these before and other people have not. And moving now to our next question. I am a freelance biomedical technician. A client who is on a tight budget has asked for advice on whether to buy a used or refurbished oxygen concentrator or not. What are some of the pros and cons of used or refurbished oxygen concentrators? Maui, if you could please answer that question.
Thank you very much, Amapri, for the question. So refurbished oxygen concentrators are used or 40 oxygen concentrators that have been inspected and then repaired and restored to an almost brand new condition. So the main benefit of refurbished oxygen concentrators is the cost. So refurbished oxygen concentrators are much cheaper compared to the brand new oxygen concentrators, with some of them going at half the price of purchasing a new concentrator. So normally what happens is they are certified and likely used refurbished oxygen concentrator. They are rigorously tested and disinfected before they are sold to the next user. So in as much as the refurbished oxygen concentrators help in saving costs, key issues need to be considered when deciding on whether to purchase a refurbished oxygen concentrator or not. So although most of the refurbishing companies offer a warranty on refurbished concentrators, such warranties mostly have a short period compared to when you get a brand new oxygen concentrator. So another key issue is the uncertainty about some of the integral parts and accessories, which may lead to the user spending more money in fixing the oxygen concentrator than they should. So should parts of the machine fail. So my advice would be, since you have a tight budget, then you can go for the refurbished oxygen concentrator, because at the end of the day, it still performs the same. All you need to do is make sure that all the necessary components are serviced. You have a high-performing compressor, you have new zeolites, all the filters are new, then you'll be good to go. So if you are working on a tight budget, then you can go for the refurbished concentrator. Thank you very much.
Thank you very much, Maui, for the answer to that. Do we have any questions or comments? I want to make one distinction, and Maui, I'm curious to know your thoughts on this. I think you've made a distinction between refurbished devices and used devices. So we know that oftentimes in countries you can find used devices, meaning something that's been used by a patient or in a facility, and that is easy to get access to, can often be rather cheap. There's a difference between those used units and refurbished units. And in my understanding, the difference is those refurbished units have a company or a provider who actually went about and checked the internal components, those critical components, the way we look at them, you know, the PC board, the valve, the sieve beds, and the compressor. And they're making sure that those are all in good condition, replacing them, making repairs, whatever, before selling those again as refurbished units. And I would think that used units, that's not the case. Those are, you know, you get them as they are. Is that something that you see as well, Maui, in Malawi or in other countries?
So we actually don't have much of those this side. So normally we just rely on the manufacturer, the suppliers bringing us the concentrators in. But you are right, as you pointed out, for the used concentrators, it's normally something that has been working, and then maybe it was placed somewhere and someone just decides to sell it. So there is no these tests that are done, or maybe the servicing. So the refurbished ones will normally get serviced before they are resold to someone else. But this side, we don't usually get most of the refurbished concentrators. And right now we're getting a lot of these Chinese oxygen concentrators. So yeah, they are brand new, but I guess some of them would say are worse off than the refurbished concentrators.
Maybe a topic for another day. Thank you, Maui. Any other questions or comments? Okay, then let's move to our next question. I am a technician working in a certain district hospital. A few weeks ago, we received training on how to fill DeVilbiss 515 oxygen concentrator sieve beds. We were given all material necessary for filling and closing the sieve beds, some of which were the closing caps and O-rings. Now that we want to fill the sieve beds on our own, we noted that the sieve beds are leaking. We tried adding thread directly to the groove on the closing cap to fix the leak, but this made it difficult to push the closing cap inside the sieve bed. How can I fix such leaks? Can we use water or petroleum jelly around the O-ring to make the cap go on easily into the bed? And Sharon, if you could please take that question.
Thank you, Amaple. So one of the challenges we face when filling DeVilbiss 515 oxygen concentrator sieve beds is the leakages, which has a negative effect on the performance of oxygen concentrator in terms of oxygen purity, and it needs to be fixed at all costs. So to answer your question, the first thing you must not do is to apply any product containing grease or oils, petroleum jelly, alcohol, or any flammable liquids on the O-ring, or use them near any oxygen generation system, as this increases the risk of fire. So using water around the O-ring is not advisable, as the water can be quickly absorbed by the zeolite and cause performance issues. So it is advisable to use oxygen compatible lubricant to easily get the O-ring in press inside the sieve bed, which removes the possibility of fire risk due to presence of flammable substances. So if this lubricant is available, an easy option is to apply several tens of thread tape type around the O-ring not inside the groove where the O-ring goes. So this will not only help the cap to go in easily, but also eliminate leakages. Thank you.
Thank you, Sharon, for that explanation. It is always very, very important to remember that oxygen is a very flammable gas, and anything that can be seen to increase the risk of fire should absolutely never, ever be done. So thank you, Sharon, for also reminding us of the importance of safety when we are working on these repairs. Any other questions or comments from the audience? Okay, then we are going to switch to our topic of interest. So this is when we take a short 10-minute break from answering questions, and we go over something in a little bit more detail. I would also like to request, as we do have some new joinees today, to please put your email in the chat, and we will be able to add you to our regular calendar invites and to our reminder emails and recap emails. So we appreciate all new members to the Oxygen Alliance and the Concentrator Talk. So our topic of interest today is going to be about a new sieve bed refilling process, and Mteto is going to walk us through that. So over to you, Mteto.
Thank you, Amapri. So today I'll be talking about sieve bed refilling process, and this has been divided into two parts. So the plan is that part 2 will be shared in the next concentrator talk. So when we talk about like sieve bed refilling process, it's basically from where you get to open your sieve bed, you put in the new zeolite, and you close the bed, you pressure test, and you make sure it's working. So in this part 1, I will only talk about like from the step where you're opening the sieve bed to where you clean the sieve bed. Yeah, so let's dive in. So to start with, over time, concentrators start to underperform due to different reasons. And one of the reasons is the degradation of zeolite, where it no longer removes enough nitrogen, leading to low oxygen purity from an oxygen concentrator. And this leads to the process where we get to refill sieve beds. So sieve beds are these canisters that contain the zeolite. So it's important to note that zeolite is very sensitive to humidity, and it is not supposed to be exposed to high humidity environment, which is 45% and above. So this means that like before refilling, you need to make sure the room you are refilling the zeolite has like low humidity. So to the next slide. So the best way to actually check humidity is using a humidity sensor that is placed inside the same room that you are refilling the zeolite. So that will allow you like to measure the humidity itself. So you can either buy a humidity sensor straight from the shop, like from different online platforms and everywhere you would search. But if you can't find them, you could as well just build your own. So if you are a DIY person, do-it-yourself person, you could actually build your own. All you need to do is to have the temperature and humidity sensor, like the one we see in the graphics on the left, the blue one. And then you could easily connect a microcontroller, it can be an Arduino, an ESP32 or anything, and then have a display that is like showing the temperature if it's necessary, but we are focused on the humidity. Yeah, so having these can allow you to actually measure the humidity inside the room. So what do you do if the place has high humidity, like the place you want to refill, let's say you want to refill the zeolite. So to the next slide, you could actually dehumidify the room. So dehumidification is actually a process whereby you are removing the moisture in air or gas And in order to do that, you could either use a dehumidifier placed in the same room with the doors closed and the windows closed to keep it sealed. So you could see on the graphics there that on the left side, we have the dehumidifier. So this dehumidifier was placed inside the OpenO2 mobile workshop. The windows were closed, the doors were closed, and you could literally dehumidify the bus itself. Another way is actually using a room that has an aircon, and that aircon has the dry mode option. So this dry mode option has actually been proved to dehumidify the room, making it acceptable for refilling. To the next slide. So using these options where you use the dehumidifier and or you use the aircon at dry mode, you could start a room with humidity as high as 59% and drop it as low as 42%. So this is what we're seeing here is actually the humidity sensor just in a blue enclosure, PVC enclosure. So this is one of the rooms here that was doing 59% in terms of humidity, and then using the air. So when the humidity looks in a good range for refilling, then you can move on to the next step. So to the next slide. So before I actually talk about the next step, I just want to quickly explain some parts of the sieve bed, because refilling involves coming across these parts. So one of the parts of a sieve bed is actually an awning. So an awning sits in between a groove of a cup, the end cup, the one that is on the top. So that end cup, if you look from the side view, you're gonna see a groove. It goes inside there. Its job is to actually create a seal so that the air inside the sieve bed doesn't escape. And then we have the filter paper. So the filter paper sits between the spring and the zeolite, keeping the zeolite in place. And its key function is mostly to prevent dust from getting into the zeolite. And another part is the spring. So the spring keeps the zeolite compacted. Remember, when we are packing the zeolite, we usually compact it. Either you're using the snowfall or you're using a concrete vibrator whereby you are compacting the zeolite. So you need a spring so that when air is introduced during the pressure swing absorption, the zeolite stays intact. And another part is the disc. So this disc can be either plastic or metal, depending on the model of the sieve bed. This one is a sieve bed from a 525 oxygen concentrator. But if you are working with an ASF, you are more likely often to encounter the plastic disc. So, but the work is the same. So its job is actually to secure the filter paper. And then we have the canister. So the canister is the cylinder that the zeolite is filled in. And we have the end cap. So the end cap is the one that closes one or both ends of the sieve bed, depending on the model of the sieve bed. And then lastly, we have, of course, this one is optional depending on the model of the sieve bed, more especially the Devil Beast 525, the round rubber. So this one sits between the zeolite and the filter paper. So its job is to allow the disc that holds the filter paper to sit properly without tilting. Yeah. So on to the next slide. So right now I'm going to talk about the next step. So this is the step whereby you're opening the sieve beds. So sieve beds come in different configurations in relation to different models of oxygen concentrators. So you can see in the graphics that there are like 3 different designs. Of course, some might find another type of sieve bed because we have like so many designs of oxygen concentrators nowadays, but these are the most popular ones. So we have the sieve bed with a nut, and this is mostly from an ASF, and then we have sieve bed with screws, mostly from J5 and other models. I think even the Ox pure, if I'm not wrong. And then we have Sieve Bed with the crib. So Sieve Bed with the crib is mostly the DevOps is 525 or the 515. So with these different types of configurations, this makes the process of opening the Sieve Bed different. So it is actually advisable to open the air inlet side first. And how do you identify the air inlet side? It's actually the one that connects from either the solenoid valve or the lateral valve to the Sieve Bed itself. So that's where the air inlet is. To the next slide. So I'll now talk about like opening the Sieve Bed in terms of an air sieve bed as an example. So an air sieve bed has like a nut at the top. So you use 11 mm spanner, a socket type preferably. So while holding the cap with your hands, you can unsecure the nut and gently remove the cap, because the spring inside the bed will have some force. So you need to be careful because it's always pushing you upwards because of the force of the spring. And some other beds actually have screws as opposed to the nut itself, but the process is the same. All you need to do is you have to hold the cap and then remove the screws. To the next slide. So in terms of opening beds, like the ones with a clip, like one we saw for the 525, or some models of the 515, you actually need to press the cap down with some force, which is most of the times impossible doing by hand because it's so hard. The spring inside, it's on a harder side as compared to the one that sits in an air sieve or a J5. So like for us, we use a Sieve Bed jig, the one you see in the graphics. So this was developed at OpenO2. So this is DIY, made from wood. So this requires just one person to actually open the Sieve Bed, as opposed to like having a lot of people holding one side of the bed and another one on the other end. So this one pushes the cap down with a good force, allowing you to remove the clip in between the Sieve Bed. And then you can use a needle nose plier or a strong screwdriver to remove the clip. So you could use this to actually open either a 525 or a 515 Sieve Bed. Yeah. So basically, that's the whole process of opening the Sieve Bed. Now I'll finally just talk about the cleaning process itself. So once the Sieve Bed is opened, the spling is removed and the filter paper is also removed. And then you can easily empty the zeolite in a zip bag to keep it safe. So we prefer a zip bag because it's like airtight sealed, so you can put it in a zip bag. So to avoid like contaminating the new zeolite, it is actually key to clean these beds before refilling them. So if you go to the next slide, please. These are like the parts that you need to make sure you clean before you put in new zeolite. So for air-safe beds, caps can be removed on both sides, allowing the canister to be cleaned with water and dried before refilling with the new zeolite. But for beds that have like one end sealed, like for the DevOps 525 and some other models of the 515, you don't have to put water inside. All you need to do is you need to insert a dry cloth all the way down, like wiping the dust around the canister itself. So we don't want to introduce water. Why? Because there's like another filter sitting at the bottom. So we don't want that filter to get wet. So after cleaning that, you can actually refill with a new zeolite. And another last thing to clean before refilling the zeolite is actually the filter paper. So depending on the condition of the filter paper, you can either blow with compressed air. So normally you need to blow from where we have the inlet of air and blow it the other side so that you remove any dirt that has accumulated on the filter, and then you could put it back. But if the filter is like badly damaged or torn, you could actually just replace with a new one. So basically, that's the whole process of cleaning, opening to cleaning of the sieve bed in regards to sieve bed cleaning. So in the next part, where we have part 2, I'm going to explain in detail from after the cleaning process. Thank you, Amapri.
Thank you, Mteto. That was a wonderful explanation and a process I think that's quite difficult. So I certainly enjoyed understanding all of the different steps before you even get to the actual pouring. Does anyone have any questions or comments? Okay, then I think we will take what is probably our last question for today. And the question is, hi, I am a biomedical technician in the eastern part of Malawi. I have just been transferred here and I am responsible for fixing all the health equipment at the hospital. I have found an air sep in the workshop and it seems someone started working on it but didn't finish and left some of the pipes disconnected. Since the pipes were disconnected, I took another air sep concentrator so that I could use it as a reference to reconnect the disconnected pipes. But to my surprise, some of the connections were different. Does this mean the other concentrator was connected wrongly, or are there different ways of connecting the pipes? Maui, if you could please take this question.
Thank you very much, Amapri, for the question. So if you go in the AirSep concentrator service manual, you see that it's actually not indicated how the pipes are meant to be connected. So they only have the wiring diagrams there. But what we have come to notice is there are actually a number of different ways in which the pipes are connected on the outlets of the sieve beds going to the patient outlets. So all these different piping methods are there to just optimize the performance of the concentrator. So they are all capable of producing high purities, only that some might take time to build up the purities. So if we look at the graphics, we have the different piping schematics that we have come across. So I've come across 3 different schematics. So the first one, which is to your far left, this one has one-way valves connected has 2 one-way valves connected after the equalizer valve. So each sieve bed has its own one-way valve, and we have an equalizer valve in between, which splits the pressure when the other sieve beds is depressurizing. The second one, which is the image in the middle, is whereby we have one-way valves that come after the equalizer valve, and we also have a pipe just below the equalizer valve where we have 2 orifices. So these ones keep allow some of the oxygen flowing from the sieve beds that's being pressurized to the sieve beds that's being depressurized. So that helps to remove the residual nitrogen in the sieve bed that is depressurizing. The third schematic piping diagram that we came across is where we only have one-way valve, and then we have an orifice on the pipe that is connecting to the equalizer valve. So this orifice is in line with the equalizer valve, and we have both of the sieve bed connected to one-way valve through a T connector. So to answer your question, the connection on the concentrator you are referencing from could be correct if they are similar to one of the piping diagrams that I've just explained here. So you can try out all of these 3 connections and see which one works best for you. Thank you very much.
Thank you, Maui, for that explanation. There's, I think, a lot of different variations of oxygen concentrators even within a brand or a model. So that's, I suspect we'll get more questions like that in the future. Does anyone have any questions or comments? Okay, then I think that will be our last question for today. I am very excited to announce that we have a new video on how to clean and repair a rotary valve. That valve is found most commonly in the DeVilbiss units, but there may be some learnings from that that can be applied to other units. So that will be on our YouTube channel and on our website. And we are very, very excited to share this with you, as well as all of the new videos that are in the pipeline. So as always, thank you to everyone for joining today for our Concentrator Talk. If you do have the chance and you are a new joinee, please do drop your email in the chat box so that we can add you to our emails and to our calendar invite so that you remember about this call. I know there's a lot of students that normally join our concentrator talks every week that are writing exams. So when they watch these videos in the future on our YouTube channel, I hope they get the good luck that we are all sending them their way right now. I know a lot of us were in, those phases of being a biomedical engineer and writing our final exams. So I'm sure we can all relate. Not me, I'm not an engineer, but for the rest of you guys that are here. And thank you very much for joining us today. And we will see you back next week on the next Concentrator Talk at the same time. Thank you.